skipped lesson 48 yesterday because lesson 48 is a good one to not have to have homework. We're not homework on Wednesdays, so lesson 48 is learning about mean, median, mode, and range, and how those values can be used to describe a larger set of data. Okay. Now, what does that mean to you right out of the blocks? What we're trying to learn today. Have you ever thought about the mean, for example, being used to describe a larger set of data? I mean, have you thought about it in that context? You look at a bunch of deals and say, okay, well, that data is about 50. You know, the average is a good kind of estimate to describe the whole chunk of numbers, right? So it's an important. The median, the same way. Mode can also do the same thing. Range, not so much. You know, the range is not going to be a description of the whole set of numbers, as it's just going to give us what? What is range? The difference between the greatest and the smallest, right? So, you know, the smallest number could be 750,000, right? And the biggest number could be 1,000,000. How would the range describe the data set? It wouldn't, right? Because the range is 250,000, which really has nothing to do with the members of the set of data. But the range is important. But don't get me wrong, but it's different from mean, median, and mode, okay, in that respect. So let's look at the definitions of these measures, what are called measures of central tendency. Measures of the center of a set of data, different ways we can describe the center of a set of data. All right, the mean is, you don't need to write these down probably, do you? No. Tell me how you find the mean of a set of data.
You
add them together and divide by the number of numbers, the number of data values, right? So the mean is the average. It's the arithmetic average of the set of numbers. All right, what is the median?
It's the middle one. When you have the data,
if you arrange them from smallest to largest,
what's the direct?
the median is the middle. What if there's not a single number in the middle? You average the two things, right? So the median is the middle number of set when they're arranged in order. If there's an even number of data values, then you're not going to have a single number that's in the middle. And if you don't have a single number that's in the middle, then you need to average the two numbers that's in the middle. One of your homework questions last night was from this section, and you had to do that. You had to average the two values together, and I think the median was 3.5 maybe.
Because it was 3 plus 4.
3 and 4 were the two middle numbers. So you already know how to do that. What's the other one? Measure central tendency. Mode. Okay. The mode is the value that occurs most frequently in a data set. There are some exceptions to this, right? What are the exceptions?
If there's like two numbers.
You could have two numbers that occur most common, or you could have three modes of a data set, right? Or you could have.
Can't you not have a mode?
Yeah, how do you not have a mode?
If they're all the same, if they're all at once.
If they all are just the same number of times. If every value occurs once, or if every value occurs twice, then there is no mode. Okay?
Do you just put like no mode?
That's exactly right. You would write no mode if a value occurs the same number of times. If a value occurs, if you have two modes, then you could call it a co-mode.
Oh my
gosh.
That's not a. Y'all didn't know that co-mode was a mathematical term. It's really bad. It's a really bad joke. Excuse me.
Video over.
No, we're okay. We'll leave it on.
I'm gonna walk out of the room.
Okay. This will be one of those days, 30 years from now, I'll lose my job somewhere because I just said that. All right. So real quickly, grab your calculators and let's calculate the mean, median, and mode of this value, the values in this data set. Now, it might be helpful to write them down. You're going to at least have to write them down for which of those three things.
The median
the median, and it's also really, really helpful to order the set to find the mode also. So it looks like the smallest value is 33 twice. I got a 34. I've got 35 three times. $36 twice. And a 38 once.
Whoa, they're all the same number. See, that's 35.
They're all the same?
Yeah, they're all 35.
Okay, so the mean is 35. If you add those together and divide by 8, the mean is 35. The mode is 35. And the median is the average of those two numbers. The average of the two middle numbers is also 35. Excuse me, the median, yes.
Yeah, it should be divided by 9.
I missed a 36.
36s.
Two 36s. Okay. Okay, that which means I'm going to actually have a middle number. Yeah, 35 is the median. You don't have to average, but even if you average them, you still get 35.
Yeah.
All right. Any issues with that? All right, so you guys know how to deal with that. Now, the range of a data set is the difference between the greatest and least values in the data set. We already talked about that. It's not necessarily. I don't love talking about the range as a measure of central tendency. To me, the range doesn't really tell you a whole lot about the center. Agreed? Now, it's still considered, it's under the topic, but I just don't. The range is something else different altogether, okay? It's different from the other measures of central tendency. Now, this particular thing, I don't want you to write anything down on this one because you're not going to have to. The table lists the total points teams scored in the two divisions of an all-star football league for the 2000 regular season, 2006. Does the North or the South have a greater range of points over the 2006 regular season? So what do we do to find the range of points for the North? Subtract the smallest one from the biggest one. What's the largest one up in the North? 427 maybe? And the smallest, you got to be careful doing it just by observation, 211?
Yeah, 211.
Okay, so that gives us a range of what? 216. And the range for the bottom set, the largest value is 492. 168.
Oh, I didn't see
All right.
168.
All right, so 492 minus 168 is 324. So the South has a much larger data range. All right. What might that tell you?
The South is a better football league. They've grown. They've either grown or.
The South has some really, really good teams and some really bad teams, right? So the range of the total points scored, these teams up here are more consistent because the range is smaller. So that may be what the range tells you. If I have a class that has a score on a test, the lowest score is 85 and the highest score is a 99, that's a range of 14 points, right? If I have a class, another algebra class, I have a 65 and I have hundreds, that's a 35. So that tells you there's a lot different ability levels or at least performance levels on that particular test. Okay, so that's kind of the kind of thing that will do. Now, it's not going to really, again, like I'm saying, it's not going to communicate to you a whole lot about the central part of the data. It's just not. So as far as a measure of central tendency, the range tells you something completely different from the mean, median, mode. All right? All right. Outliers. Are y'all familiar with what an outlier is?
Yeah.
Now,
Talked about it last
the textbook kind of tells you this is how you mathematically determine what an outlier is. Now, this is really odd to me, Mr. Saxon, if you're listening, because you've not been taught any of this. Quartile 3, quartile 1. You've not been taught in Saxon up to this point how to identify the 4 quartiles of a set of data. All right? Well, so quartiles. So what this is saying is that if a data point is less than the quartile 1 value by 1.5 of the inner quartile range. Okay. Now again, none of that's been defined, but they're throwing this definition at you as if you've been doing this quartile stuff forever. The good news is you're not going to need to know that ever until you take a statistics class in college or in high school, and then they'll teach it to you. You're not going to assume that you know it. Now, for our purposes, an outlier is a data value that is much greater than or much less than the other values in the data set. And it'll be obviously larger or obviously smaller. Okay? And this is really, if you do study and know what this means, 1.5 times the inner quartile range is going to take you way away from the average of the set. Okay? So that just kind of helps you see. Okay? Here's an example. The following data show the high temperatures in degrees Fahrenheit for the first 15 days of July 2007 for Seattle, Washington. Okay, certainly not South Haven, Mississippi. Only one of these would be a good estimate for for temperature in July, right? Yeah. Does this data set have any outliers? 98.
Well, not really. Okay.
What's the next closest data value to 98? 89 is the next closest one. That's pretty far, right? Now let's talk about how the other values are closer together, right? Why wouldn't 75 be an outlier? Because there's a 76, there's a 70, couple of 78s. Those are pretty close, right? So 75 is the only other possibility, but it's pretty darn close to these other 3 values. There's 3 values that are close to it. There's really not one value that's relatively close to 98. Now, what do I mean by relatively close? Compared to how close the other values are. That 98 is going to fall outside of that 1.5 inner quartile range. So 98 is definitely an outlier. Now, describe how this outlier would affect the measures of central tendency.
Throws off the average.
It's going to throw off the average, isn't it? It's going to raise the average temperature because it's 9 points higher than the others. 15, 9 over 15. It's going to raise the average temperature by over half a degree. And that's going to be a big deal. We're not going to take the time to do it, but it's 9 points over 15 spread out over 15 values. That's a big deal. If you take it out, the average temperature is going to be considerably lower. Anytime one data value changes the whole set by almost a point, that's a big deal. Okay. So if we had a class of 20 people and I wanted to affect the average by 1 point by adding one score, that score would have to be 20 points higher than the other scores. So it would definitely be an outlier, right, to do that. All right. So the average, it's going to raise all of the measures of central tendency. Now I could ask you to be specific. What's the average with the outliers? What's the average without the outliers? Okay, That's easy to calculate, right? As long as you're clear on what an outlier is. Now, here's an example of how outliers can affect things related to advertising. Okay, this says that Supergrow Fertilizer placed its advertisement in a newspaper. Is the statement in the advertisement true? Okay, so is the statement in the advertisement true? We're going to need to read the advertisement to see. Does the statement accurately describe the data? All right, so here's the statement that we're looking at. So we've got all these watermelon weights. Here's the statement. Supergrow watermelons have an average weight of over 8 pounds. Is that statement true? Use your calculators and tell me if that statement is true. It's true. What is the average? 8.1 repeating. Is it repeating? Okay. So there's 9 values. Okay. The second statement says brand X watermelons have an average that's under 7 pounds. That's an interesting way of putting it, right? A negative connotation. It's under. It's less than. Under 7 sounds worse than over 6. Is that true? It's not true? Brand X?
Mine says 6.5.
6.5 repeating?
Yeah, that's what mine said.
Yeah.
Okay, so 6.5 repeating. Now, what's wrong with this boast?
Well, over 8 pounds makes it sound like it's a lot over 8 pounds, and it's like 8.1.
Okay.
Under.
What else?
And under 7 pounds, it's only like 0.5 points under 7. So
All right. What else?
the 20 is an outlier.
Yeah.
20 is very much 20 is very much an outlier. You could probably almost argue that the 10 and the 20 are outliers. Now, it's not, the 10's not going to statistically be an outlier.
If you take the 20 out, you get 6.6.
If you take the 20 out, our average is 6.6, which is just barely less than 6.5, right? What's the range of the Supergrow fertilizer? 16 pounds, based on this data.
So you could either get the tiniest watermelon ever, or you could
So you could get, anywhere from a 4-pound watermelon to a 20-pound watermelon. Now, is that what watermelon growers want? No. They want consistency. And so, based on this, does it really, are they really, is Supergrow fertilizer really a superior fertilizer? I wouldn't think so. The range of this other data is 4 pounds, right? So all of our watermelons are nice and grouped together. So we can talk about a lot of different data as it applies to these things, but you got to be really, really careful in advertising, right? Advertising, they'll look for and they will use outliers to their advantage all day long, because they're not going to use any data that would make their product look bad. Hey, let's go find some data that makes our product look bad. They're not going to do that. So really, I want to kind of caution you guys to this extent. Nearly all advertising is false advertising. It is a very one-sided story. They're going to spin it perfectly, so you can't really believe it. I can remember, Jay when he was a kid, and Josie too. Oh, Dad, we've got to get that one. Why do we have to get that one? Because they said it's the best. Or, oh, Daddy, let's go see that. This is the best movie of the summer.
Like on
The
world's best coffee.
Yes, congratulations, the world's best coffee. Yes, you did it. Yeah, that's the kind of thing that you have to watch for. But if you know your mathematics and you can look at data set, and this kind of, this is never more true than when you're looking at statistical studies that show a drug is great, or if you look at a statistical study that shows that a drug is terrible. They're all skewed. They're all going to take a little data sample from somewhere that supports their opinion. Okay, so you just gotta be careful with those types of things. You can use statistics to say anything you want to say if you just go get the right set of data. Okay? All right, so that's lesson 48. We're not going to have an assignment from this lesson, but you just need to be prepared to answer questions.